Okay, Year 10, I'm just going to go through these questions from drawing straight lines. And I'm going to do some of the first ones in case there are some people who've been away and missed it. And I know you're doing it in class already, but I'm going to go over it and then I'm going to do the parallel and the perpendicular. So first of all, I'm going to start with one of these harder ones here. I'll start here with some of the questions on just drawing straight lines. So what we want to have when we try and draw a straight line is we want to have it in the form y equals something x plus something. Now I'm using m and b because that's the standard way that people use to describe this, or the standard form, where m stands for the gradient, which is the rise over the run, the slope or the angle, whatever you want to call it, and your b is your y-intercept. Now, when you do these, you want to write it in that form. By the way, when you move to advanced maths next year, they change that letter to a C, but they keep the M. They're just constants. It doesn't matter what they use to describe them, as long as you understand what they mean. Now, what we want to do is we want to draw this equation over here. So I've got y equals 2x plus 3. Now straight away, I know that this equation goes through 3 because it's written that way. There's my y-intercept of 3. That's the first thing you do. Then I know that this has a positive gradient, which means it's going up from left to right. So it's going to go like that. Now, a gradient of 1 to 1 produces an angle of 45 degrees. And you can find that by going, if the gradient's 1, if m equals 1, tan of the angle equals 1, because it's opposite over adjacent. And therefore the angle equals inverse tan of 1, which is 45 degrees. Now, if the gradient is steeper, like in this case, which has 2 to 1, this angle in here will be something different. You can find that angle, tan theta equals 2, by going inverse tan of 2. And I'll just get my calculator out. And if I go inverse tan of 2, I get 63 degrees. So you can find the angle. So straight away we know that this thing is pretty steep. So it's a straight line going like that. Now on this OneNote, I don't have rulers. I know I've tried to use them. I know there's a ruler over here, but it's difficult to use. So I'm just going to let that go. Make sure that you're drawing these with a ruler. The key now is to find that point, the x-intercept. Now there are two ways. Well, they're not two ways. There's only one way, but one way is a shortcut. To find any intercept, you let y equals 0, to find the x-intercepts, you let y equals 0. So you get 0 equals 2x plus 3. Now then this is an equation, and all you've got to do is solve it. So you minus 3. Some people like to think I'm moving that 3 over by minusing it, but I'm minusing it from both sides. And I divide by the 2, minus 3 on 2, which is minus 1.5, but I like to keep it as an improper fraction. So minus 3 on 2. And that's the important bit. And you get that, and away you go. The other way to think of it is to go, well, if I change the sign of that, which is moving it to the other side, and divide by that. So minus 3 on 2. All right. Now let's move on to some that are a bit more difficult. So here I've got 5x minus 2y plus 3 equals 0. Well, that's not written the way I like it. And remember, the way that you like it is y equals, and the y must be positive. So I'll take that y over the other side and I get 5x plus 3 equals 2y. I added 2y. And now I'm going to divide everything by 2. So 5 on 2x plus 3 on 2 equals y. Now it's written the way I like it. It's written y equals 2.5 x plus 3 on 2. I'm going to leave it as 3 on 2. I know it's 1.5, but that's the way I like to write it. So again, this is going to be even steeper than this angle because it's a bigger number. So when I graph this, it has to be steeper. And it's going through 3 on 2. So if I go over here and I mark 3 on 2, so 1.5, 3 on 2, and this thing's going to be very steep. It's going to come through there. Now, if you were doing this in an exam and you did that, I'd take a mark off because you didn't use a ruler. But I'd give you 2 marks because you've got the y-intercept and you've got a pretty good idea of the gradient. The key is, can you work out this? So over here, I can just change the sign of that and divide by this. But I'm going to do it the step-by-step procedure. I'm going to let y equal 0. And I'm going to have 0 equals, and I'm going to write this as 5.5x, 5 on 2x, sorry, plus 3 on 2. You watch what happens. I minus the 3 on 2, and I get 5 on 2x. And I'm going to divide by 5 on 2. I'm going to multiply. Oh, that's just multiplying by the reciprocal. So minus 3 on 2 times 2 on 5. And look at that. The 2's just cancel, which gives me minus 3/5, which when I draw or look at my diagram makes sense. And I mark it minus 3 on 5. And that's how you graph straight lines, especially when they're in the form y equals mx plus b. So let's have a look at parallel lines. Well, parallel lines are similar. So I'm just going to take this one here. Now, you are, in this instance, and I've been very kind, marking all the points, or marking the lines that are parallel to the equation I've given you, but are through 0, 2. And you're lucky because that's the x value and that's a y value. So 0, 2 is the y-intercept. So I've actually given it to you already. So let's do this one. Well, if 2 lines are parallel, their gradients, m1, are the same if lines are parallel. So let's write this equation, which is 3x minus y minus 6 equals 0. And I'm going to take the y over the other side and I get 3x minus 6 equals y. So this line has a gradient of 3 and a y-intercept of minus 3. But I don't want that one. I want the equation parallel to that and through 0, 2. Well, if it's parallel, it's got the same gradient, so it's y equals 3x. And because it goes through 0, 2, that's y-intercept. Okay, so it's going through 2. And the last ones we drew were 2, 2.5. So this is even steeper. So there's my line. Now I have to find this. I'm going to do it the quick way this time. I'm going to minus that and divide by the 3. So minus 2 on 3, minus 2/3. And if you can do this and do it really quickly, you're away. I want to do one that has a negative gradient, so I'm going to quickly do this one here. First of all, I have to write it as y equals. So when I write it as y equals, I've got to have the y positive. So first of all, I'm going to take that 2x over the other side and that 4 over the other side. So I get 3y equals negative 2x plus 4. I'm not too worried about the plus 4 because remember I'm finding the parallel one. So now I divide by the 3 minus 2/3 x plus 4 on 3. But I'm not worried about that because The equation I'm graphing is the one that's parallel to that. Oh, so it's y equals minus 2/3 x, and it's going through 0, 2, so plus 2. So here, it's going to go through 2. Now, 2/3 is not a big number, but also it's going down. It's coming down. So it'll be like that, because it's a negative gradient. Now I've got to find this point. So again, I'm going to do it quickly. I'm going to minus that, minus 2. If it was plus, if it was minus, I'd add it. And I'm going to divide by negative 2 on 3. Well, that's the same as multiplying by negative 3 on 2. Oh, and watch what happens. The 2's cancel. Negative 3. That point is negative 3. And that makes sense because the gradient is the rise 2 over the run 3. And there you go. So that's parallel, perpendicular. So what do you do for perpendicular lines? If two lines are perpendicular, their gradients, when multiplied by each other, equal -1. And that has a really good way of finding out the gradient, because if you have two lines that are perpendicular, I can divide that m2, I get -1 on m2. Essentially what you're finding is if it's perpendicular, you take, to find the gradient, you take the negative reciprocal. So here we go. Now it's really interesting because the first one here, the first two are the hardest. So I'm going to do these two on the left, but I'm going to start with this one here. So here's the equation. Y equals -3 on 2x plus 5. Well, the gradient here for this line is -3 on 2. So the gradient of the perpendicular one, I just change the sign, so it's positive, and I turn it upside down, 2 on 3. So my equation for the perpendicular line is y equals 2/3 x plus, well, I have to find the y-intercept. Well, that's in part of the question. Again, I've given you the y-intercept, it's 0 and 2. So it's just 2. So here we go. It's going to go through 2, and it's got a gradient of 2/3. So it's positive, and it's not so steep. Again, to find this point here, I change the sign of that, -2, and I divide by that. Oh, that's multiplying by the reciprocal, so to multiply by 3 on 2, the 2's will cancel, and I get -3. And again, that makes sense because rise over the run is 2/3, and that's a gradient. What about this one here? What about this one here? So 3x minus 2y minus 6 equals 0. Now remember, the y has to be positive, so I'm going to take that y over the other side. 3x minus 6 equals 2y. And I have to have a single y, so I'm going to divide by 2. So 3 on 2x minus 3 equals y, because I divided everything by 2. I divided that by 2, I divided that by 2, I divided that by 2. Now, the gradient is 3 on 2. I'm not worried about the y-intercept. So for my equation, m1 equals 3 on 2. Well, the perpendicular one, m2, I just change the sign, negative, turn it upside down, 2 on 3. So my equation of this perpendicular line is -2 on 3x. And again, I've told you the y-intercept, it's 2, so just plus 2. So it's going through 2. This time it's negative. It's not very steep because it's only 2/3. And again, to find this point, the x-intercept, I'm letting y equal 0. Realise that's what I'm doing. I'm letting y equal 0. But a quick way to do it is to change the sign of that. So -2 and divide by that, which is multiplying by the reciprocal. So you multiply by 3 on 2, negative. The 2's cancel, and negative, it becomes 3. And again, as we've seen for the last couple of times, that makes sense because that's 2 and that's 3, which is the rise over the run. So good luck with those. Make sure you get them done and have a play on Desmos, and I'll see you next lesson.